Tracking warm eddies in a cold sea. The Labrador Sea is an arm of the North Atlantic Ocean that lies between Canada and Greenland. In the winter, cold, dry winds blow over the sea, cooling most of the water to near the freezing point. A warm boundary current, called the Irminger Current, enters the Labrador Sea from around Greenland, supplying heat to replace what the cold winds remove. About 6 times a year, a rotating loop of warmer water pinches off from the Irminger Current and drifts slowly away into the open sea. These rotating pools of warm water, called Irminger rings, eventually fall apart and disperse their cargo of warmer water into the interior Labrador Sea. Not much is known about how much warm water they carry, where they go, and how they die. Scientists working at the Woods Hole Oceanographic Institution are about to find out. Starting in fall 2007, they will place sets of sensors and floats in the Labrador Sea, directly in the path of the newly formed Irminger rings. The sensors will be suspended on a cable anchored to the 3,000-meter deep seafloor. Some sensors will measure water temperature and salt content, while others measure current speed and direction at many depths between the surface and the bottom. Near the top of the mooring, 6 profiling floats will be loaded into each of 2 carousels. A temperature sensor will detect a warm Irminger ring passing by and signal one of the carousels to release a float into the ring. The innovative carousels and release mechanisms were developed by scientists and engineers at the Woods Hole Oceanographic Institution, and this is the first time such technology has been used in an oceanographic experiment. It represents a new and exciting advance that allows oceanographers to remotely release floats into rings. As an Irminger ring comes by the mooring, the temperature sensors will detect its warmth, and a profiling float will be released into the middle of the ring. The float will be trapped in the ring and drift along with it. As the float drifts along with the ring, it will periodically inflate a rubber balloon, which makes it more buoyant and causes it to rise up to the surface. It measures the temperature and salt concentration of the ring on its way, and then deflates the rubber balloon and sinks back down again. Each time the float rises to the surface, it will transmit the temperature and salt content information it has collected to a satellite high overhead, using cell phone technology to phone home. The float gets its position from a global positioning system receiver and transmits this information with the rest. Each time an Irminger ring passes by the mooring, 1 float will be released, until all 12 floats have been remotely seated into rings. The float will travel with the rings, periodically transmitting their information until the rings slow down and fall apart, which may take several months to a year. With our new technology and the information gathered by these mooring sensors and profiling floats, we will learn much more about Irminger rings and the impact these warm, swirling water masses have on the cold Labrador Sea.